Hello everyone, greetings of the day. Dear authors and invited guests, welcome to the technical session 5D. Myself Prashi and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th version of International Conference on ICT for Sustainable Development ICT4SD 2025 Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On the ninth minute, I will be raising a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or update, then you can write it to me in the chat box given down below. And just before we start our session, I would like to introduce you all to the chair for our session. Dr. Priyanka More. Dr. Priyanka More is an assistant professor in the Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune, India. Her research interests include image processing, machine learning, natural language processing, and the Internet of Things. With a strong academic background, she is dedicated to advancing research and fostering students' learning through innovative teaching methodologies and technological advancements. We welcome you to the session, ma'am. Our first presenter for this session is Pallavi Dhared, presenting a paper on the title A Sequence to Sequence Approach for Text Summarization using by LSTM Networks. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, thank you
Pallavi.
so much. I'll be sharing my screen right now.
Yes.
Again, a very good afternoon, everyone. I am Pallavi Daded, a fourth year student from KLE Technological University. The paper title is A Sequence to Sequence Approach for Text Summarization using BiLSTM Networks. So these are the contents of the presentation. So coming to the introduction part, the process of generating summary of huge set of information while maintaining the actual context is called text summarization. The generated summary should be fluent and concise throughout so that it is easy to understand. And the model which we have proposed generates abstractive summaries of the source text. The motivation behind this project is that summarization helps turn large amount of information into shorter, easier to read form. There is a lot of information present online and reading all of it is insufficient and inefficient. Summarization makes this task easy and simple by highlighting the essential parts of the source text. Summarized information can improve decision making by highlighting only the most relevant facts. It can also make complex topics easier to understand by focusing on the essentials. Summarization is especially useful for professionals who need to review large documents like researchers, doctors, and business people. Summarization tools are highly valuable now as they help you to stay updated while saving time and effort. We have considered three main objectives: accuracy, relevance, and fluency. Accuracy: the summary must accurately capture the source text meaning. Relevance: the summary should be relevant to the source text. Fluency: the generated summary should be easy to read and should be grammatically correct so that it is understandable. Coming to the dataset description, we have used Samsung dataset from open sources, and the dataset is intended for dialogue summarization tasks. This is the block diagram of the proposed methodology. We have taken the data set and processed it in various steps. We have processed the data set, tokenized it, and extracted the features. Then we have built the model, trained it, and evaluated it with the blue scores. And if there were any changes required, we have done them, and the final model is ready. Coming to the pre-processing steps, firstly, we have converted all the text to lowercase so that it is concise throughout. And we have removed any HTML tags, URLs, and emojis, which are not very much useful when generating the summary. We have expanded the contractions like I can't to I cannot, and we have converted chat abbreviations to their full forms like BRB to be right back. Further on, we have used Keras tokenization to convert text to sequences, and we have added special tokens for start and end to mark the beginning and end of the sequence. And we have added padding sequences to keep the length uniform. Coming to the model architecture, we have used a bidirectional encoder to capture information from both direction in the input sequence. And we have used attention layers to focus on the most relevant parts of the input sequence. Model compilation is done using Adam optimizer and sparse categorical cross entropy algorithm. These are the implementation details. So pre-processing is cleansing of the text by removing HTML tags, emojis, URLs, and expanding the contractions. And then we have tokenized and added padding sequences to get a fixed length of the sequence. And then model architecture is the encoder is bidirectional LSTM, and attention mechanism focuses on the relevant parts of the input, and decoder is a LSTM sequence generator, and training is done using Adam optimizer and sparse categorical cross entropy loss. Evaluation is done using blue scores. In the results section, we have the graph of loss per epoxy and accuracy per epoxy, and we have conducted it for 5 epoxy as the graph gets saturated after 4 epoxies, and the obtained blue scores is 90.23. In the conclusion, BiLSTM encoder with attention enhanced decoder improves the contextual understanding of the sequence pattern, and capable of generating readable and relevant abstractive summaries from informal dialogues. Thank you very much.
Thank you so much for your presentation. Dr. More, do we have any questions for ma'am?
Yes, ma'am. Okay.
Yes, ma'am.
So, yeah, Pallavi. So, can you just tell me which data set you have used?
Ma'am, we have used Samson.
Okay. So, is it authentic data set? I mean, is it verified by other researchers?
Yes, ma'am. We have looked into a few papers that have used this very same data set. So, yeah, it is authentic.
Okay. And how you decided to use Adam optimizer and other algorithms?
Ma'am, it was just an approach that we thought of including in our model, and we consulted with our professors with these, and they said that they were good enough for dialogue summarization. So we went ahead and used them.
Okay. So, is there any comparison you have done with other methods? Other researchers have already worked on this?
Yes, ma'am. There is this base paper that we referred to, which is titled as Abstractive Summarizer using BiLSTM, and they have used BiLSTM networks as well. And our result and their result is comparable. There is a difference in the attention mechanism that they have used, and the results are quite comparable, ma'am.
Okay. What is the specific application, whatever methodology you have suggested?
Yes, ma'am. So we initially intended it to be for AI chatbot generation and stuff, and that is the future scope of it. Um, it was actually intended for practical chatting. That is how we came up with this model, and we are still working on it.
Okay. So yeah, that's what my suggestion, that you take the actual real-time data set and you just train on that.
Yes, ma'am.
Okay. Yeah. Yes, ma'am. That's it from my side.
Thank you so much, ma'am.
Thank you so much.
Thank you. Yeah, thank you so much for giving me this opportunity to share our work on this platform. Thank you so much.
Yeah, great. Pallavi, keep progressing in this.
On that note, I would like to call upon our next presenter. Our next presenter is Abhirami K, presenting a paper on the title AI Ate My Job: Impact of AI Anxiety on Career Anxiety and Career Uncertainty. I request you, if you are available with us, to kindly take over with your presentation, please.
Hi, ma'am. Can you hear me?
Yes, ma'am, we can hear you.
Yes, ma'am. Thank you so much. Good afternoon, everyone. Today I'm here to present about our research title paper, Impact of AI Anxiety on Career Anxiety and Career Uncertainty. Yes, I am Abhirami K and my team member Naina, with the guidance of Dr. Shobna Madhavan and Dr. Deepa Gupta from Amrita School of Business, Coimbatore. We have explored how the fear surrounding AI affects career related anxiety and uncertainty. So these are the table of the contents. And here is, as AI technology grow more sophisticated, they create massive shifts in how the work is done. On one hand, they boost efficiency and open up to the new job opportunity. On the other hand, they also trigger anxiety. So AI anxiety is defined as a distress and fear, how people feel about losing their jobs or having their skill replaced by AI. And it creates creates career anxiety, worry about career choices and job security, and it also creates career uncertainty, which is a lack of clarity or confidence about the future career path. Today, I will show you how information theory, which highlights three vital needs. So we see plenty of headlines directly investigate how people anxiety and career uncertainty. Prior studies don't connect A anxiety with career. Research fills the gap by analyzing these from real respondents across India. On the various moving on to the conceptual model, using the top of the model career uncertainty, we also test over their career and relate how much they are capable to feel. A anxiety is higher, then they experience higher career anxiety and career uncertainty, but strong autonomy or life satisfaction could reduce them. Moving on to the illustrative hypothesis, H1 state, if an individual with higher level of A anxiety are likely to experience higher level of career anxiety. And if the life satisfaction is higher, then they tend to have lower career anxiety. Higher career anxiety leads to higher career uncertainty. Individuals with higher A anxiety are more likely to experience higher career uncertainty. These are the scales of constructs that we used in our model. Next. Moving on to the methodology, we adopted a quantitative approach and surveyed 240 respondents across India using a structural online questionnaire. The survey covered career decisionness, career uncertainty, life satisfaction, autonomy, competence, relatedness, plus demographic details like age, gender, education, and income. To test our model, we used a structural equation model and mediation using Stata software. And this is the descriptive data which we include in our questionnaire, and we have been input this is aligned to the SDGs 3, 4, and 8. So now let us see about the result that we got from the analysis. So according to this Cron branch alpha table, competence recorded the highest reliability and following to autonomy, relatedness, and life satisfaction and career anxiety. All are comfortably above the threshold of zero point 0.7. So Reliance has the lowest but still acceptable reliability at 0.7337. These variable confirms that our construct are reliable and stable. Following to the SEM and MedSEM analysis, A anxiety significantly predicts career anxiety with a beta of 0.53 and p-value less than 0.01. This means higher A anxiety leads to higher career anxiety. So A anxiety also predicts career uncertainty with a beta value of 0.603, and again it is highly significant. This means fear about A make people feel more unsure about their career future. Interestingly, autonomy has a positive effect on career anxiety with a beta of 0.256 and p-value less than 0.05. This means seeming that even people with strong decisions making control aren't immune to a anxiety. So life satisfaction showed a negative beta value, that is minus 0.271 for career anxiety, meaning greater well-being helps lower career anxiety. So, relatedness, competence, and AI resilience did not have significant effect on either career anxiety or career uncertainty. Our mediation STEM reveals something crucial. We checked A anxiety effect on career anxiety acting as a bridge. The results show no significant mediation, meaning A anxiety affects career uncertainty directly instead of flowing through the career anxiety. So our findings confirm that A anxiety is a clear driver of career stress and career indecisions. So the limitation of the studies are actually this study is limited to the Indian samples, and longitudinal quantitative research is needed to track AI anxiety over the time and explore deeper personal and contextual factors like organizational support, career adaptability, and career literacy. So, conclusion is that by recognizing and addressing AI anxiety, we can better support individuals navigating their careers in the fast evolved technology era. These are the reference articles that we have been taken from for our research. And thank you for giving this opportunity to present about my research in the platform.
Okay. Um, Abhinani,
Yes,
Priyanka
ma'am.
for decide. Yeah. So a good research topic you have chosen. Just tell me that whatever values you have shown, alpha and all
Yes.
these values. So how you are relating to your outcome? How you define all those values?
Ma'am, using Strata software, we have been collecting the data through Google Sheets, and we have been uploading all those data in the Strata 14 software. So we do few codings in that, and we do get the results of this.
Yeah, that's what I'm asking you. That how we have came to the conclusion that relatedness and whatever values you have shown, autonomy and all this. So it was coming that. So any algorithm, any specific processing or operations you have perform on that?
No, ma'am. Only SEM and MedSEM analysis.
Okay. What are the different fields in your Google form?
Okay. Actually, it is career undecisions,
Yeah.
career
Any other?
uncertainty, then life satisfaction, then relatedness, autonomy, and competence.
Okay. So have you directly asked these questions in Google form?
Yes, ma'am.
Okay. And how these values, so that's why I'm asking you that how these values are related to each other. So whether how we have came to conclusion or which analysis you have done. I mean, which algorithm you have applied for this.
Ma'am, algorithm in the sense like,
Like you have written, no, that these are the relatedness value and some alpha values you have shown, right? So
yes,
can you
ma'am.
just go to
Ma'am,
that slide?
actually, we have been coding like for alpha value, we just put a code and it will generate these alpha value and how much these variables are dependent to the how career anxiety affects career uncertainty, how AI anxiety affects career uncertainty and career indecisions.
Yeah, that's what I'm asking you. How you are defining this? That one variable is related to another one. Okay, fine. Yeah, that's it from my side. Thank
Okay,
you.
ma'am. Thank you so
Thank you
much.
so much, ma'am. Thank you so much for your presentation. Now I would like to call upon our next presenter for this session. Our next presenter is Shreya Ratagal, presenting a paper on the title AI Generated Realms, Crafting Images from Text with a Stable Diffusion Model. I request you to kindly take over with your presentation, please.
Yes, ma'am, sure. Article from Kelly Technological University, Hubli. So today I am delighted to present our project titled AI Generated Realms, Crafting Images from Text Using Stable Diffusion. So this work was guided by Professor Satish Chekmat and done in collaboration with my team members Parvati Navlur and Amruni Joshi. So our focus is on how artificial intelligence, especially stable diffusion models, can generate creative and realistic images from just a line of text. So here is a quick overview of the presentation. I'll begin with the introduction, followed by our motivation and objectives. Then explain our methodology, the evaluation metrics we used, the results we obtained, and finally share the conclusion and future scope. So let's begin with the introduction. Here, the text-to-image generation is a growing field in artificial intelligence, where machines are trained to create images from natural language descriptions. So it combines natural language processing and computer vision, enabling AI to understand a prompt and visualize it. So we used a model called Stable Diffusion, which operates in latent space using a process called denoising diffusion. So here the text prompts are encoded using a transformer-based language model, and then the image is decoded using a variational autoencoder. So this makes the process faster and generates high-quality images. So coming to motivation, the main motivation behind this project was the growing demand for tools that can quickly transform ideas into visuals. So this technique eliminates the need for manual drawing or expensive tools and enables rapid prototyping. It's beneficial in education, training, design, accessibility for people with disabilities, and much more. It empowers users, even those with no artistic skills, to generate content using just text. So, our core objectives were to explore AI's ability to generate creative and realistic visuals from text, to assist designers and educators in quick visualization, and to study how this method can enhance accessibility, improve engagement in entertainment, and support automated marketing content. Just a second. Okay. So, okay, before I explain each step of the methodology in detail, here is a quick look at the workflow diagram of our project. So, this diagram shows the entire process starting from the text prompt, followed by the preprocessing, tokenization, and vectorization. Then we apply dimensionality reduction, add Gaussian noise, and use the stable diffusion model to perform denoising in latent space. Then finally, the variational autoencoder reconstructs the image into pixel space, giving us the final output. So this is the full pipeline we follow for generating images from text. So now let's look at our methodology. So we use the Leon 5B dataset, which contains over 5 billion text image pairs, making it ideal for generalization and diversity. Next, we reprocess the text by removing stop words, converting to lowercase, and handling out of vocabulary terms. Then tokenization is done using special tokens like CLS and SEP. After tokenization, we apply vectorization, converting text into structured numerical form. These vectors are high dimensional, so we use PCA or autoencoders to reduce complexity while keeping semantic meaning intact. So in the image generation phase, we use Gaussian noise. So this model is trained by adding noise to an image in steps and then learning how to reverse this noise iteratively. So this teaches it to reconstruct clean, accurate images from scratch. So we selected stable diffusion over conventional methods because it performs generation in latent space, not pixel space, making it highly efficient. At each reverse step, the model aligns the image with input text. So finally, a pre-trained VA is used. Here, the encoder compresses the image into latent form, and then the decoder reconstructs the image from denoised latent data. So this makes the whole pipeline lightweight and fast without compromising the image quality. So to evaluate our model, we used both quantitative and qualitative methods. Coming to quantitative metrics, which include FID, which measures similarity between real and generated images, where lower is considered the better. And next, IS, which measures realism and diversity, where higher is considered the better. But numbers alone do not capture creativity or accuracy. So we also conducted human evaluation. Reviewers assessed how well the images matched the prompts and judged aesthetics, structure, and creativity. So, this holistic evaluation ensures we are not only generating images but the meaningful ones. So here are the results for different prompts. The first one, prompt one, a charming village of hot air balloons over lavender fields. Here the model captured balloon shapes, lavender texture, and cottages. It shows the strong spatial awareness and color harmony. Next, prompt two, here a majestic mountain landscape. In this image had detailed snow-covered peaks, lush green slopes, and dramatic lightning. And also the depth and realism were very impressive. The prompt three, an astronaut exploring a strange alien planet. So this surreal sci-fi image had glowing rivers, floating crystals, and a solitary astronaut. It demonstrated the model's ability to handle abstract, imaginative prompts and clarity. So to conclude, our project demonstrates the power and potential of stable diffusion in the field of text-to-image generation by operating in latent space and leveraging techniques like denoising diffusion probabilistic models and variational autoencoders. The model produces high-resolution, semantically aligned visuals in an efficient manner. It supports a wide range of applications from educational tools and marketing design to accessibility and creative arts. In future work, we aim to focus on improving prompt precision, fine tuning the model for specific domains, and addressing important ethical challenges like bias and responsible content generation. So that's bring me to the end of my presentation. I would like to sincerely thank our guide, Professor Satish Chekmut, my teammates Pavati Navlur and Amruni Joshi, and the ICT4SD organizers for this opportunity. So thank you all for your time and attention.
Yes, Shreya, am I audible?
Just a second.
Yes, ma'am, you're audible.
Yeah. Okay. So you have not implemented this?
We have implemented, ma'am.
Okay. So you have not shown any evaluation metrics for this?
We have done, but I have not added it in the presentation.
Okay. So you need to add that. And another one is, have you compared it with the real time conversion we are using nowadays, text to image,
Yes, ma'am.
with which one?
Actually, we have kept a base paper like utilizing AI. So we have done the comparison with our paper.
No, no. I am asking you that nowadays we are using Gemini and many models, no, other chat GPT models.
Oh, okay. Ha ha
For
ha.
text. Yeah. So have you compared, have you tested it that if you are entering some text and entered by this model also, and are you getting the same type of image?
No, ma'am. Sorry, but I have not yet done that. But
Okay.
further, I'll surely do it.
Okay, great. So do it also. Yes.
Yes, ma'am. Sure.
Thank you.
Thank you so much for your presentation.
Thank you, ma'am.
Now we'd call upon our next presenter for this session. Our next presenter is Nishant Sharma presenting a paper on the paper title IoT for Early Warning Flood Systems. I request you to kindly take over with your presentation, please.
Yes, ma'am. Thank you. Good afternoon, everyone. Today, I, Nishant Sharma, will be going to present my research paper based on IoT for early warning flood system. My team members are Mohit Singh Melawat, Mohit Sharma, Ayush Kumar Singh, and Gagandeep Singh from Manav Rachna International University. Our mentor is Dr. Kamlesh Sharma, who is Associate Dean in MRIRS. So our IoT-based early warning system work to detect floods. These systems use real-time data collected from our interconnected sensors to monitor environmental conditions. By using cloud computing and AI/ML, the system can analyze this data quickly and issue alerts before a disaster strikes. This allows authorities and communities to make faster decisions, take preventive measures to reduce risk of people. So this system is designed to detect natural hazards like floods or environmental threats early. These systems rely on sensors that collect real-time data. The data is then processed using cloud computing. The goal is to reduce disaster risk and improve community preparedness, especially as climate change and urbanization increases. The frequency and impact of such events also increases. The illustration on the right shows how sensors monitor the environment and transmit data to alert authorities and people in vulnerable areas. So, why do we need such systems as we already have traditional systems? But we need such systems because of urgent need for improved flood detection system. Between 2009 and 19, flood caused over 50,000 deaths and around $370 billion economic damage. Traditional flood warning systems are often expensive, slow, and less effective, especially in developing countries where resources are also limited. This highlights a pressing need of affordable real-time and automated solutions, which IoT-based early warning systems can provide faster alerts and help in preventing loss of life and property. The limitations of traditional warning systems is delays due to manual data collection and reliance on hydrological method. Although some systems use satellite data, they lack real-time accuracy. They delays These delays can be critical during disasters. In contrast, IoT-based solutions provide real-time monitoring and automated alerts, allowing quicker and more reliable responses. However, in many regions, limited infrastructure and high human dependency prevent timely alerts, making early evacuation and disaster response challenging. This highlights the need for automated real-time and scalable solutions like IoT-based system. IoT technology enhances flood disaster management. It does this by using interconnected sensors to collect real-time data, enabling faster prediction, quicker responses, and effective remote monitoring. Technologies like GSM, LoRa, and LPWAN IoT facilitates transmissions, early warning, and automated responses in remote areas. So, IoT-based flood warning system explains that IoT-based system check water level using sensors and transmit data via Wi-Fi or GSM. Machine learning is also used to improve prediction accuracy based on previous flood data. The challenges based on The key challenges based on IoT based for flood warning system is power issues, sensor durability, and network reliability in tough environments. Handling large data also needs cloud computing and analytics, and using renewable energy resources is crucial for uninterrupted operation during floods. So this is comparative analysis on between the systems which are used in USA, UK, and Europe. FloodNet is a system used in Europe. FloodNet is very cost effective but it is limited to urban areas and relies on LoRaWAN technology, which may not be available everywhere, and so low cost sensors may lack precision. FloodSense, which is used in UK, provides more accurate data using multiple sensors, but it is costly, complex to set up, and depends heavily on strong network infrastructure. The Aquatrol, which is used in USA, offers high precision monitoring but comes with high installation and maintenance cost, which could not be provided by developing countries. The last, Flood City Sense Europe. Uh, Flood City Sense Europe involves the public in data reporting, which is innovative but depends on active citizen participation and reliable smartphone access, making it vulnerable to data inconsistencies and digital divide issues. So this is our system design, which is the workflow. Uh, it explains the proposed system design using IoT components. It employs ultrasonic sensors to detect water level and GPS to pinpoint flood locations. When water reaches a critical level, a solenoid valve is triggered to release excess water and prevent flooding. The system is controlled by Node MCU ESP8266, which is a central unit for the whole system. It is basically the whole sensors will report it and it will go to our application for real-time monitoring and alerts. So this is working mechanism of our system. Our system continuously detects the current water level and classifies it into three stages: safe, warning, or critical. When the level is safe, the solenoid valve remains off and water level data is simply sent to the mobile app. As the level rises to the warning stage, the system sends alerts through the app and activates the solenoid valve to begin draining water. If it reaches the critical stage, both alerts and GPS coordinates are sent to the app, allowing users to avoid flood zones. This automated process improves public safety and helps prevent flooding disruptions. This is our microcontroller setup. The role of ESP8266 microcontroller, which is central to system's IoT functionality. Its feature is built-in Wi-Fi, allowing it to wirelessly transmit sensor data to the cloud or mobile app in real time. The ESP8266 connects directly to components like ultrasonic sensors and other IoT components, making it ideal for live flood monitoring. So these are important points which shall be known for our project. The flood monitoring system relies on well-integrated setup of hardware and software. Multiple water level sensors, including ultrasonic sensor, are placed at various points to gather real-time data and water behavior and at surface levels. These sensors send data to ESP8266 microcontroller, which acts as system's brain, processing inputs and enabling IoT connectivity via Wi-Fi. So The integration between hardware and software will lead to the automated responses and the current GPS flood activated location in our mobile app. So at last I would like to conclude it by this IoT based flood monitoring system present a smart cost effective solution for early flood detection and public safety. By integrating ultrasonic sensors and real-time mobile alerts, this system ensures timely response to rising water levels. Despite certain limitations, the proposed model demonstrates how affordable technology can be used to protect lives and infrastructure, especially in flood-prone regions. With further development and scalability, this system has the potential to make disaster management more efficient and proactive. These are the references from which we have gathered these informations. Thank you everyone for your patience.
Thank you so much, sir. Ma'am, do we have any questions for him?
Hello. Yes.
Yes, ma'am.
Okay. So let me know that you have tested this on real-time data set.
Yes, ma'am. We have used certain real-time datasets.
Okay. So how many sensors you have actually installed? How you have
So, ma'am,
collected the data?
yes, ma'am. We have installed all 3 to 4 sensors. First is for water level sensor, which is used to detect present water level, and other is ultrasonic sensors, which will tell us the location from the highest water level. For example, if we are living in Delhi and the flood arises in Gurgaon, so it will detect how much far is that is from us.
Okay. Okay. Good.
Okay, thank you.
Yeah. That's it from my side.
Thank you so much, ma'am. Thank you so much, sir, for your presentation. I would like to call upon our next presenter for this session, please. Our next presenter is Jigme Nidab, presenting a paper on the title IoT-based health monitoring system using 4-in-1 electrogram sensor. If you are available with us, I request you to kindly take over with your presentation, please. Mr.
Uh,
Nidab, yes. Okay.
Hello, can you hear me?
Yes, sir, we can hear you.
Can you see my screen?
Yes, we can.
Okay, presentation. Uh, Good afternoon, everyone. Respected Dr. Priyanka Moore, representative from IST, fellow authors and presenters and guests. I am Jimmy Nirup from Vellore Institute of Technology. My research paper is IoT-based health monitoring system using 4-in-1 electrogram sensors. My team members are Aditya and my guide is Dr. Naresh K from VIT. This is my content. I'll begin with introduction, some literature reviews, problem formulation, STG, system, descriptions, tools, and results. This is my topic is based on the 23rd research about 11 to 23% of AFib cases. AFib means atrial fibrillation. It means irregular rhythm, heart rhythm, which goes undiagnosed and causes stroke, heart problems, blood clots in many people. Also, not only in focusing on heart, we're also focusing on brains, sleep patterns, which are linked with brain problems like epilepsy, Alzheimer's, and Parkinson's disease. Right now, our research gap has found that most of the existing electrogram signal devices focus on single parameters like ECG only or EMG only, muscle signals only. And for that, we are proposing and also demonstrated a model using a multi-sensor wearable where we can detect all of this in one device with an average of like estimated 90% accuracy. Literature reviews. This talks about multimodal biosensors, which proves greater accuracy We are also using IoT enabled systems which for real time health tracking, monitoring, and messaging. Gaps identified are the complexity involved is high. There's a cloud dependency for these models. Another challenges we have found is that most of these devices, health devices, are extremely expensive, and because they are extremely expensive, most people don't opt to test their health in regards to such signals, which prove greater accuracy in predicting and finding diseases. So we have delayed diagnosis, which increases healthcare costs. So we have developed a very low cost system, about $47, which is approximately around 4,000 uh, rupees. So this is the relevance to sustainable development goals, good health, innovation, and it reduces the inequality. This is our proposed system architecture for the device and also the cloud part. The device part involves multiple biosignals such as brain, eye, heart, muscles, and also the body temperature. We have a sensor which detects all these electrogram signals, which is converted by ADC, and then it is processed in a microcontroller, and then we have a button to switch such modes because we can't detect all this signal at once, so we have a button to switch the signals. We have a display to showcase the status, and then we are transmitting it using Wi-Fi to the cloud. In the cloud part, we are using a IoT protocol, MQTT, and we also have a web backend, web front end, and a backend which has the AI models built in. This is the internal architecture of our device. We are using the ESP32 JAW, which has a built-in Wi-Fi. It is very small, cheap, and it has a built-in ADC for it. We are using body temperature sensor, OLED screen for display, and the EXG pill sensor, which is a single channel multi-purpose sensor for electrogram signals. And we also have a button to switch modes. And this is our data flow. The user will provide the electric signals, and this will be captured. Then it will be transmitted over Wi-Fi to the server, where we have a CNN model built in, which will predict the diseases and then send back to the user. It will also store this data for further use, and also we have a web display to display these results. We also have notifications for body temperature and other stuffs, the use cases. These are all the use cases that the user can use. Now, how we trained? We used the PhysioNet medical data set database for data sets to get our data sets. First, we took the raw signals, processed it, extracted the features, made a data set, and then trained the model. We tested that signal to get the model accuracy, and then we did a real world experiment using new raw signals. So first we acquire signal, then filter using the ESP32, and then transmit to MQTT for cloud and CNN inferences. This is the picture of how we are placing the things, and this is are the model accuracy that we have found, and this is based on the medical data set, not on like a real world test. So this is our hardware tools. We need electrodes and connecting wires. This is a front back image of the device. It has the temperature sensor module. On the front image, we have the button and the display along with the sensor for the electrogram signals. So this is the device cost we have measured. All in all, in total, it comes around $47.4, which is in current conversion, it amounts to 4,000 rupees, which is very cheap for the amount of inferences we can do and work it can achieve. So this is the result analysis using our web dashboards. This is just screenshots from the website we have created. So these are the test signals from the FizoNet datasets on how the electrogram signals looks like. So we are using CNN models for finding the pattern and then matching it and predicting the disease. So we have achieved integrated 5 sensors into single variables. Also, it is cost effective and scalable. But the limitation is it's a single channel data, so it is not as accurate as the big machines, which is like 12 channel, 14 channel models. And it's also cloud dependent. The impacts it can have in hospital societies, it can reduce hospital visits. We can like do our own checkups in our house for like just early signs, and also reduce impact on the environment. So our future plans is to collaborate with healthcare for clinical trials to just test on patients to validate our models and device, and also monitor respiratory conditions. This is our references. Thank you.
Thank you so much, sir. Ma'am, do we have any questions for him?
Yes. Yes, good work, Jigme. So
Thank you,
just
ma'am.
let me know. You have mentioned cost, right? Cost of the total
Yes.
system. Okay.
Yes.
So when you will, or if you want to make production of your system, your
Yes.
devices, okay. So who will use this product? Normal
Uh,
user or
yes. This is
hospital?
for like a normal user, not a hospital device.
Okay. Okay. Fine.
So this is not meant to like accurately predict everything. This is for like early detection mostly.
Okay. So in previous slide, first, I think second or third slide, you have mentioned that outcome is the type of disease or disease name you will get, right? So in your
Yes, it
methodology,
is.
I didn't see anywhere that how many diseases you have identified through your system.
It is actually shown in the CNN model prediction. We have a fixed. We have predicted for a fixed set of data set with the diseases, and then trained on that.
So you have shown in slide because
I can show.
yeah, please.
Here we have the classes for like EMG. There's a normal signal. EMG is the signal for your muscles. There's a
Okay.
myotherapy and neurotherapy. These are the two diseases. For like ECG, which is your heart, there's a normal and the atrial fibrillation, which means irregular heartbeat. For like
Okay.
EOG and EEG, which is like eyes and brain, both of them are interlinked, where we can see awake, NREM sleep, and REM sleep. So based on how much you are having like NREM and REM sleep, we can see whether your sleep is good or not.
Okay. So model accuracy is your model working, right?
It is based on the data set provided.
Okay. And that data set is available on internet, right?
Yes, it's from PhysioNet dataset.
Okay. Okay, fine. What about the pre-processing? Feature pre-processing you have mentioned in methodology, right? So which different
Yes,
techniques you have used for pre-processing?
the pre-processing is done actually at the device itself from ESP32 device
Yeah, but
itself.
what is that?
Uh, it is like just we have when we sense from the sensor, it senses the electrical signal in like values from like 0 to like 3 volts. So
Yeah.
this is like now pre-processed into numbers, ADC numbers.
So that's it.
Yes. This
Okay.
is a time series data set. Mostly we are not actually looking at how high the value is, but the pattern that is formed overall in a time.
Okay. Okay. So you have mentioned CNN you have used, right?
Yes, is to like
Okay.
detect the patterns.
Okay, good. So can you tell me what is the architecture model of your CNN you have used? Layers and all this thing. How many
Uh,
layers you
I've
have used?
I've used 6 layers.
Okay. And what is the parameter value? Parameter strength, number of parameters you are generating from the CNN.
Um, Basically, the dataset has like different. I have made different CNN models for different signal types. Like EMG have its own CNN model. For EMG, it is around like 1.1 million. For like EEG, the brain signals, it is around like 7 million datasets. And then for the EOG, it is something around 1 million.
Okay. So just think on this also. You have used MQTT, right? And you're using ESP and all this. And if you have
Yes.
millions or billions parameters in your CNN, so will it create transmission error or some other kind of error? So just look into that part also.
That was the training data set. For actual like inferences, we take around like 1 minute of data,
Okay.
1 minute of reading, which comes around 30,000
Okay.
points, data points.
Okay. Good. Yes. That's it from my side. Thank you.
Thank you so much, ma'am. Thank you so much, sir, for your presentation.
Thank
Now,
you.
thank you so much. I would like to call upon our next presenter for this session. Our next presenter is Harsha Imar, presenting a paper on the title Kicking Goals with AI, Football Analysis Using YOLO and OpenCV. I request you to kindly take over with your presentation, please.
Hello, hello.
Hello, sir.
Is my screen visible?
Now it is visible, sir.
So, good afternoon, everyone. I am Arsha from Kelly Tech University. So, our project was based on the Kicking Goals AI on football analysis using YOLO and OpenCV. So, our background and introduction is in the recent year, ML and computer vision was in seen in significant growth, and the football was being one of the most followed sports against the evolution. And the coach, analysis, and the fans incredibly seek the methods to obtain the real-time insights into the players and performance and the team. And the project is centered on the creating a football analysis system to evaluate the advanced tools like YOLO and OpenCV. So in our local football matches and leagues and all, in present days we don't use advanced technologies or anything, or just a manual coach looking at the player and deciding the match analysis and collecting the data, like how the player is. So this lack in accessibility in data means and for next generation superstars, which often start in these leagues, and they can be overlooked. An automated system can be evaluated. Detection could be provided for faster and better analysis for the player and ensuring they don't miss potential talent. So our methodology is input and pre-processing. So we take the video of the match and we make convert into each frames, and the YOLO V5 model then classifies identify the players, football, and referees and the goalkeeper. And we classify the teams by the players A and B by their jersey colors. And by that, we start analyzing the player speed and distance they covered. So the key finds in the detection and tracking are the object detection. This project employs in the YOLO identifying players, roughly football in video frames. Trackers are then used to monitor these objects across the frames. So we use key beam clustering to utilize the pixel segmentation to accurately characterize the players into teams based on the jersey colors. So the camera motion, the optical flow is implemented to measure the camera movement between the frames, allowing for more precise tracking for the player movement. So the key finds in the performance matrix, the system applies perspective transformation to accurately depreciate the scene depth and perspective. This transformation allows for the measurement of player movement in meters instead of pixels, leading to more meaningful data. And speed decisions are based on the measurement by these calculations of each player's player speed and total distance they have covered within the frames. So we trained our model in the using the data set which was available in the RoboFlow, and we used the data set which had 663 images. So the precision confidence was the overall precision of all classes reached one at the confidence threshold at 0.870. So the players had the very high precision, and the recall confidence was the model achieved overall the recall of 0.60 at the confidence level. So the data analysis and statistics insights was the F1 score of the player was around 0.80. So in the overall F1 score of the class peaked at 0.56 at the confidence threshold 0.19. So the mean average precision was across all classes 0.569. So in the classification accuracy, normalized metrics showed a correct classification rate of 0.79 for the players, 0.58 for referees, and 0.51 for the goalkeepers. So the results were that YOLO and OpenCV offered the strong and feasible foundation for the development of sports analysis. And this also what helped us in multi-class detection for players, like examples like players, referees, footballer, and goalkeepers. And the model demonstrated the high precision, especially for the players, which is more critical for the performance and analysis. So these are the results graph which we got after training the models. And the significance with this technology responds to the demand of automated analysis to provide the low cost solution for the professional sports and empowering local leagues. It can provide the local leagues with data analysis tool they currently lack in helping in talent. And so and so this is the results which we get after the models after we run the analysis. So after when we feed the input matches of any matches, so it classifies the players based on their jersey colors, and it signifies the classes based on the referee and all. So these below is the distance and above the speed the player is moving across the field. So it can segregate, and these arrows, the red arrow indicates that the next the person who is going to kick the ball, and the ball is marked as green with green arrow. So conclusion was this project successfully developed an automated system for football analysis by integrating YOLO leading object detection model with OpenCV, and the system addresses the increasing demand for real-time tracking of players and ball detection for both professional and employing in multi-class detection method, calculating the key metrics like speed, distance, and project showcasing the practical real-world application machine learning. And the technology has potential significant benefit coaching, broadcasting, and performance evolution. So future research is to improve the model with high accuracy on different class at low power, low performance, low performance like goalkeeper and referees, and expand the feature set like enhancing the system recognition more complex in the game event, tackling the pattern, which is the formal pass shots. So real-time optimization focuses on the pipelining of efficient and real-time deployment using live matches. So I would like to end my presentation here. Thank you.
Thank you so much,
Okay.
sir. Yes, ma'am. Do we have any questions for him?
Yes. What is the contribution in this?
So we try to use the lowest models such that we can deploy in less computing powers like NVIDIA Jetson Nano something, so that it can use less resources and give.
You have used only machine learning, right? So machine learning for video processing, is it sufficient?
Not really, like when it goes to more complex videos on the, then we need a high level AI models which can predict the future and making it less burden for the ML to do the work.
Okay. So have you compared your work with other work, other researchers had did already?
So yeah, there are some premier leagues, like the top end broadcast people who have done it. So according to their metrics, we are slightly lacking on the precision of the distance and the speed of the players, as they use high level sensors, and we are just using the raw video to generate all those things.
Okay. Okay. Good.
Thank you.
Yes, that's it from my side.
Thank you so much, ma'am. Thank you so much, sir, for your presentation. Now I would like to call upon our next presenter for this session. Our next presenter is Arushi Madan, presenting a paper on the title PCOS detection in ultrasound images using transfer learning with Inception V3 and ResNet 50. I request you to kindly take over with the presentation, please. Ms. Arushi.
Hello, a very good afternoon, everyone.
Good afternoon, ma'am.
Let me just share my screen. Is my screen visible?
Yes, ma'am, it is visible.
So, very good afternoon, everyone. My name is Aruchi Madan, and today I'm going to present my work on polycystic ovary syndrome detection using machine learning approach. So, polycystic ovary syndrome is a common hormonal disorder in women of reproductive age that causes multiple cysts on the ovaries, which you can see in the figure 1. The up image is the normal ultrasound image, and the second image is the PCOS defected image. So it leads to the formation of basically multiple cysts inside the edges of the ovary. Now, despite the technological and research advancement, the exact root of PCOS still remains unknown. So Classifying PCOS using ultrasound images is quite challenging because the ovarian appearances can vary subtly between the patients. So currently, this diagnosis mostly depends upon the expert radiologist, which makes it subjective and really time consuming at times. So for my objective, so developing an efficient and automated classification method can help with early detection, which reduces the human error and make diagnosis more consistent and accessible. Uh, in this approach, I have applied and compared my two pre-trained models using transfer learning approach. The models are Inception V3 and ResNet 50 models. These are evaluated and analyzed using the performance matrix. And for my literature review, many studies was we came across many studies that used CNN approach. They have custom CNN models were made. Also, many machine learning and deep learning models were used using convolutional blocks, and certain accuracies were achieved. And from that, the gap was filled that transfer learning approach is yet to be explored. For my methodology, the data was collected. Image pre-processing methodologies were taken on, and using the transfer learning approach, the classification of infected and non-infected images were then classified. For this, ovarian ultrasound image dataset was collected using the dataset was divided into the three categories, which is train, validation, and test. And as it's a binary approach, there were two files, which is infected and non-infected. Where infected, the cystic ovaries were present, and in not infected files, the healthy ovaries ultrasound images were present. For data pre-processing, all the images were of different size. They were all firstly resized for the consistency of the dataset to 224 pixels, and also the dataset was normalized to 01 using the image data generator process. As to generalize and to make our model robust, the image augmentation technology was also used using shear range, zoom range, and horizontal flips, which increases the data variability. And for the batches, 16 batches were used, and using the binary classroom. Basically, transfer learning model, it is a pre-trained deep learning model only, which is again used for the related task only. The weights which are already being used for the previous models, it is applied on the newer model. Now, why Inception V3 and ResNet 50 were used? As they have proved to be a better approach for the medical image classification, and for as availability of these deep representation of complex features, we get to as it's our better approach. Now for Inception V3 model, it's a deep convolutional network which is developed by Google only. And as it's a part of Inception family only, which is known as Google Net, it basically improves on the earlier version, which is better for accuracy and efficiency, especially on the large data sets like ImageNet, as it's trained on ImageNet only. So why Inception makes it unique? Because traditional CNN stacks layers sequentially, but Inception modules use multiple filter sizes in parallel with the same layer only. For example, 1 on 1, 3 on 3, and 5 on 5. So this lets the network capture both local and global features, which very beautifully aligns with our model, because as the cyst sizes vary from image to image, so Inception was a better approach for us. As Inception V3 also has 48 layers deep, counting only the layers with the parameters only. So it is composed of Inception modules, factorized convolutional layers, and auxiliary classifiers. And for this model architecture, the images were, as already told, it was resized to 224 pixels, and the frozen layers were the non-trainable layers, which were used to learn the features. And for output layer, we use the sigmoid, as it's a binary classification, and Adam optimizer was used, and binary cross entropy was used for the loss function. Coming to ResNet 50 model, ResNet 50, which stands for Residual Network with 50 layers, it's a deep convolutional neural network which is developed by Microsoft research, and it is basically designed to solve the degradation problem in deep networks, which basically adding the more layers, which leads to the higher training error. Basically, residual means like traditional deep networks struggle to learn or identify the mapping as they go very deeper. So ResNet introduces the shortcut connections that skip one or more layers. These shortcuts add or add the input directly to the output of the block, forming the residual connection. For the experimental setup, the training, validation, and test set were split. And for hardware, it was implemented on the Jupyter notebook with the Keras and TensorFlow backend. And for training details, 16 batch size was used using Adam Optimizer. And for also early stopping was used for SNet 50 to prevent the overfitting. Our Inception V3 model achieved the highest accuracy of 99.68 if when compared to ResNet 50 model with 100% precision and F1 score of 99.68, which gave the better and higher accuracy. These are the training and validation accuracy graphs along with the confusion matrices. So this study presented an automated PCOS detection using the transfer learning approach using the two models, which is Inception V3 and ResNet 50. And my future work includes like to expand my data set for more diverse ultrasound images and also to integrate the multimodality data set for my further approach. And for model exploration, ensemble learning and more customization CNNs can be used, which will further help to boost the accuracy and generalization of the model. Thank you so much.
Okay, good. So just tell me one thing.
Yes.
What is this data size, that data set you have used?
Data set, 1 second, I can go back to. So my data set is around 2000 images, where also the data augmentation was performed on the training set.
Okay. So you have taken only two classes, right? Infected and non-infected.
Yes, ma'am. There are only two classes for PCOS related data sets.
Okay. So is there anything that in infected is any stages and all this thing?
I'm sorry, can you please repeat?
Under infected, can we have other subclasses again? That stage 1, stage 2, and all this one?
Ma'am, actually, there are not any particular classes, but on the basis of classification, where the multimodality data sets come, there comes the variety in the segmentation part. If that is my future work only for segmentation, by using segmentation, we can detect the size of the cyst and the number of the cyst on which we can basically classify it is whether it's stage 1, stage 2, or stage 3.
Okay, so depending on the size parameter, that is your future work, right?
Yes, it is around something 0.35 mm, and if it's more, if the cyst is more than that size, we consider it to be in the stage 2, along with the number of cysts that are present in the ultrasound images.
Okay, so if I have a new data,
Yes, ma'am.
how much time it will take to give me the result, that infected, not infected?
If it's fed into my system, my model.
Yeah, that's what I'm asking you. So you have used two models, no?
Yes, ma'am.
So how much time will your model will take?
Um, um, it should take 15 to 20 minutes.
Minutes.
Yes, ma'am, minutes. As 16 batches are used and the overfitting problem, because as the background is gray, so it's difficult for the classification and segmentation part. So it requires 15 to 20 minutes to run a model to give the accuracy that is there present or not.
Okay, fine.
Yes, ma'am.
Yeah, that's it from my side.
Okay, thank you so much.
Thank you so much, ma'am. Thank you for your presentation. Now we will invite our next presenter for this session. Our next presenter for this session is Omkar Shinde, presenting a paper on the title Predictive Analysis, and clustering of autism spectrum disorder in children using AQ10 data. I request you to kindly take over with your presentation, please.
Yeah, I'm audible to you all.
Yes, sir, you're audible.
Yeah. Okay. Is my screen visible to all?
Yes, sir, your screen is visible.
So, very good afternoon to all. My name is Omkar Shinde. I'm a student at the Pimpri Chinchwad College of Engineering, Pune, and my paper is on predictive analysis and clustering of the autism spectrum disorder in children using AQ10 data. So basically, this is like a through the PPT we can cover like abstract introduction, literature review, research gaps, then methodology, result, and comparative analysis, and then for conclusion and future ones. So basically, autism spectrum disorder is like a common neurological disorder which affects the someone's behavior, social interaction. It's like a one in 68 children in India, and throughout the globally, it is like a nearly a 3% out of 100. So, in this condition, mostly someone is icing out himself or herself from the society, and his social interaction is very much less, and his cognitive abilities such as the calculational or like communication skills are very much affected. For this autism spectrum disorder, we take the data set, like I can explain it later. So uh, in usually the society thinks that these children are the underdeveloped, uh, they have underdeveloped brain. So mostly society try to icing out, like separate it children from the uh, society. So we have to like not separate out it, but we have to cure their disease, and that's why we have literature review. In a team, we reviewed the more than 17 papers, but a few are mentioned here, such as that the machine learning based model for early stage detection of autism spectrum disorder. So in this paper, mostly they uses the machine learning models to detect the whether a person is suffering from ASD or not. So they uses models such as like a support vector machine, then the AdaBoost, then flexible discriminant analysis. Also, there are more models such as the logistic regression, then decision tree, random forest, etc. And SVM achieved the highest accuracy in their paper. Uh, and also, there is a, like a classification of ASD in three categories, such as the ASD can be detected in early childhood, then in like toddlers, and then in adults. So we can go. So basically, we found that the research gap is such as that, like AQ10 data set, there was not too much study on the AQ10 data set, and also like there should be an improvement for the screening, such as like uh, mainly whoever the researcher, they try to parsing the all 10 questions to the models, but we think that the 10 questions are high, like we can pass the 8 or 7 questions and try to achieve the same accuracy. And also there was no research related that the how ASD traits are like uh, how ASD traits is related to the age, such as that the whether in a child, early childhood it is highly riskable or not, and also there is a lack of clarity of development timeline, such as that it is highly developed in early childhood, or it may like uh, develop in toddler, or maybe when you go to the adult and you do not talk to the society, and it's starting get developed. So this we use the data set from the Kaggle data set, and it consists around 1,000 entry with 19 feature, And uh, proposed methodology for this is like we took the data set, and then in processing we do that the sanity check of data, then removing the null values, and then we will try to then we apply the feature extraction. Feature extraction consists of three steps, such as the variance threshold, select k-base, and select percentile. All the three methods we try to apply the elbow method, so we can find the like correct and the like optimized value for the respective parameters. And then after the applying all feature extraction methods, we conclude that these many features are needed for our models, and then we try to implement the cluster analysis and then model training. Then we will compare the model training, and we will generate the inferences. So here is the my comparative analysis for the feature selection method. So here you can see that all 10 questions are needed. Like as you can see, they are passing through variance threshold, select k-base, and select percentile, while the age in months, ethnicity, jaundice, and family with ASD is not too much needed as to the model. So these all AQ 10 questions are numerical figure, like yes and no answer is was there. So there are all numerical figures which is mapped to 0 and 1. We use the heat map analysis for to detect the which question is least significant to the model, or least significant relevant to the other questions. So you can see here AQ10 question is least significant to all other questions, since it has a relation like 0, 0.02, 0.05, etc. Here, for the clustering analysis, we using the Elmo method, we find that the three number of cluster optimized cluster will be three, and zero cluster represent the high score, which means that cluster zero represent the higher risk of ASD, while cluster two represent the lower risk of the ASD. As you can see, in a our while the age is progressed, the higher risk is increases, which means to occur ASD in a early childhood can be easily highly riskable. While as you can see for the lower risk, there is a chance that if you are in low risk zone, so it may be possible that after little bit curing, you can ASD traits will be go down significantly. As you can see here, it goes down and become a constant. Lastly, for the model, we try to implement logistic regression, support vector machine, decision tree, and random forest. Another one is the I think Gaussian. Uh, and we try to implement, and we find that the SVM performs much better than the all other models, since logistic regression always try to use the 100% accuracy. We try to remove it using by regularization technique, like it is overfitting obviously, so we try to remove using the uh, like uh, regularization techniques such as the L1 and L2, but still didn't achieve overfitting is not removed, so we stick to the SVM gives the highest accuracy. When for the feature elimination method, we try to remove question one by one to detect that the which question reduces the highest accuracy. Basically means that the if question is removing the accuracy much affects the much accuracy, it means that it is an important question. While question removing the less accuracy, it means it is the least significant. So as you can say, when there is a no question, our model achieving that 99.05 accuracy, and while AQ one question when removed, and we pass the AQ10 to AQ10 question, AQ2 to AQ10 question, we achieve the 96.53 accuracy, decreasing with the 2.5 accuracy from the 99. Same with goes with the all 10 questions. If we remove the AQ2 question, we will pass 9 questions such as AQ1, AQ3, and onwards. So we can see here AQ4 is the least significant question to the contributing to our model, and then second for the second number AQ10 question is there. So here highlighting point is EQ10 is coming twice since it is does not have the correlation with the others also, and here also for the feature selection method it is not needed, and it does not contribute to our model too much. So our final conclusion is that the since our early accuracy is the 99.05%, still when we remove the AQ4 and AQ10, we were able to achieve the 98.1% accuracy. So it is a very less, it means it is a very less decrease in accuracy, and also we find that the uh, early childhood ASD can be highly riskable as compared to the others. Our future work will be try to expand this data set, and also we want to explore and work on the EEG and eye tracking data set. These are my references. Any question? Hello?
Ma'am, do we have any questions for sir?
Hello.
Hello, ma'am.
Hello. Yeah, am I audible?
Yes, ma'am, you're audible.
Okay. So have you taken concern of any doctor working in this autism disorder detection?
Yes, we take a concern regarding the which is the government doctors from our normal district in Pune. So basically they said that the most of the since doctor have most of the data set containing EEG and eye tracking data set, they don't have the AQ10 questionnaire data set. So we thought to taken it from the network only, which is available on Kaggle. Yes.
Yeah, that's it.
Thank you so much for your presentation, sir. Now I'd like to call upon our next presenter for the session. Our next presenter is Vijayalakshmi S. Kati, presenting a paper on the title Sensing the Future Revolutionizing Pest Detection in Agriculture Through Sensor Driven Deep Learning Techniques. I request you to kindly take over with the presentation, ma'am.
Thank you. Is my screen available visible?
Yes, ma'am, your screen is visible.
Okay. Yeah. Good afternoon, everyone who are present there. Today's my topic is on sensing the future, that is revolutionizing pest detection in agriculture through sensor-driven deep learning techniques. So why I have taken this topic is it's one of my PhD literature review where I'm going to talk on why the pest detection plays an important role in uh, agriculture. Why? Because most of the plants, if we try to identify the harm which are caused by the pests at the earlier stage itself, we can protect the harvesting of the plants as well as we can increase the yield in the agriculture. So that's why this is the area what I have chosen for. So, in order to identify the pest induction or the presence in the soil, if we do, that will be very helpful in reducing the harmful effects what is being caused through the pest. So, these are the reasons why most of the agriculture harvest, especially in Karnataka, if we consider in the plants like arecanut or the sugarcane or rice, ragi, any plants what you take, which are the most of the staple foods what are being consumed by the people, are being at a loss because of these reasons. And every day by day, we are coming up with new kinds of pests or diseases which are being causing the different plants every time. So I took a challenge that let me see the way how we can integrate these aspects with our technology and let our technology help the farmers to identify the detection and detection of these diseases at the earlier stage, and it can give them a better yield when compared to the yield what they are getting. So, to discuss with the as the introduction, the integration of advanced sensor technologies and the deep learning methods to address the pest detection are the challenges what are there in the agriculture. Pests, particularly the soil dwelling larvae or the post significant threats to crop yields and the economic stability, which have been at a higher risk, as I said. And traditional detection methods, what have been used previously, like a visual inspection by digging up the soil and then removing those pests or the larvae which have been found in the soil, will take more time for the farmers. So that can be avoided when we incorporate these sensor technologies with the technologies what we have right now. So it is always an inefficient and an invasive way. So to overcome with that aspect, we have considered this. So the main objective of my review is, or this paper and my work is review the pest identification research, what we have done, and what are the different ways to identify using different technologies, where we are going to make use of the sensor technologies, and we focus on the deep learning aspects, the conventional methods what we have, and integrate all of them to detect the pest identification at the earlier stage with a more accuracy rate, so that we can find the best solution, and we can increase the yield in the agriculture. So the main challenges what was there is why we have to do this in the agriculture is it's all because of the labor intensive works, like we can't get the labor right now. If we talk about the farmers, they always have the complaint that we are not getting the labor, and the labor cost what is incurred for cultivating any crop is very high. But at the yield, once they have finished the process of cultivating the plant or any crop what they are growing, the profit what they get is almost equivalent to the cost what they have inputted for that crop. So we can increase that. So that can be done through our techniques. So lack of scalability and fail to provide the timely and accurate data due to pest infestation, when it is occurring, what time it is occurring, that can be identified. And it also depends on the nature, climate, as well as this type of soil what they are using, and the type of habits what those kind of pets have been having. We can identify that. So different sensor technologies have been used for identifying these kind of pests. Like we can use our image sensors, which are used for capturing the visual data, but are been always affected by the lightning and the conditions, which have been used. Acoustic sensors, that is detect below soil activity, but are influenced by environmental noises also. And soil sensor, which are going to generate us the soil properties, but are again limited with the spatial coverage, how much we can coverage. So considering all these aspects, we can take on different parameters and see how we can incorporate these things. So recent advancements, they have incorporated all our IoT integrations and improved the data interpretation, so that using that data, what they have collected, we can apply the deep learning models and get the accurate data for detecting the pests. So according to our literature review, I could find out that using the image sensors, what were the advantages, what are the disadvantages for using these types of sensors. When we use image sensors, the high resolution data is the advantage what we get. Depending limitations are depending on the lightning conditions what affects our data. For acoustic sensors, detects the activity below the surface, but due to the environmental noises, it can also tamper our data. When we talk about soil sensors, yes, it gives us the most of the characteristics of our soil, but the limitations of that is spatial coverage, how much area we can cover, and what are the other properties, and what type of soils it's going to affect will be the parameters to be considered. And including these all parameters, we can select the data on which we can take the decision, which will help us to identify the detection of pests, whether they are present or not. So, as I said, we can incorporate our deep learning techniques for that. So, what are the different models I can use for analyzing this? Is models like CNN I can use, or RNN, or LSTM. These are the different analyzing sensors for identification of pests where these algorithms can be used. And evaluation is measures what we can use for evaluating the performance. We can use our recall F1 score or precision or rock or the different evaluation models what I can apply on these things. So some of the sensors which are already integrated and how it has been working and what kind of results what they have achieved by incorporating these, I have analyzed with different reviews what I have done. So this is the scores what is being given after evaluation for different methods. When we apply the CNN, this is the precision. What does our precision level gives, or what recall F score or AURC gives the results depending on the different algorithms has been analyzed with my review what I have done. So depending on different study cases and applying different model and different sensors, these are the outcomes what I got for the first study in a paper. What I found is with the image sensors and soil sensors, by applying the CNN, we can improve the accuracy in identifying the pests. Whereas only acoustic sensors, along with the RNN method, we can identify real-time detection of our pest activities. With the study of soil sensor and a combination of LSTM, prediction of optimal conditions with the pest can be identified. This is what the overview I could find with my readings. So what are the different challenges? What I'll be facing here is the data quality issues. As I said, different parameters are there which are going to affect me in collecting the data and to take the decision which data to be considered, which not to be considered. As I said, the data quality issues are the environmental factors which are going to affect the sensor performances and robust challenges in our deep learning models. So all this put together will, after solving these issues, we can find out the actual results. So ethical concerns include our data privacy, ownership, and the environmental impact. What can happen for these when we incorporate. So talking about the future, technological advancements that development of next generation sensors, UAV sensors or swarm robots or satellite based technologies for precision identification in agriculture can be incorporated as time goes on. And how are we going to implement those is enhance scalability, user-friendly interfaces, and energy-efficient designs for widespread adoptions can be incorporated in future. So to conclude, the integration of sensor technology and the deep learning has the potential to revolutionize the pest management in agriculture by enabling the precise, timely and sustainable solutions for our problem. And it also going to improve crop yields, reduce economic losses and enhance environmental sustainability, paving the way for resilient agriculture systems. So these are the different references what I have referred for going through my literature review. Thank you.
Thank you so much, ma'am. Dr. More, do we have any questions for her?
Hello.
Hello, ma'am.
Yeah. So can you name some sensors? Name of the sensor? You mentioned soil moisture, but any value or any?
pH sensors is there, ma'am.
Okay. So how
pH
many
sensors.
sensors you have used?
No, I have not implemented anything, ma'am. This is my literature review to start my work.
Okay, but you mentioned somewhere, no, integration of some sensors and all this.
Yes, ma'am. We can make use of pH sensor, where the pH sensors will help me to identify the different properties of soil, like what is the warmth in the soil, the moisture content in the soil, how much water is there, as well as the smell can be identified with the pH sensors.
Okay. So
Acoustic
based on your
sensors,
literature review, have you proposed anything?
based
What
on
is your
that,
conclusion?
my
What is the
conclusion is
conclusion?
Yes, ma'am. We can make use of image sensors. That is, in case if I'm going through with the upper part of the plant, if I'm considering rather than considering soil, we can make use of the pictures where using the thermal cameras, I can identify the presence of any pest.
Okay. And what about the range of sensor? Because it
Uh,
should be like it should capture some bigger area also,
yeah.
right?
Yes, ma'am. That is
Have
what
you
the
considered those
scale issues
papers?
are there to consider here.
Yeah, please.
That's what, ma'am. Scalability issues are there, but the range of that is approximately within the smaller area only, ma'am. It's not a huge area when we consider thermal area. So, what my intention is, take a low cost sensors with which are not going to be very high for the farmers, and take the data from those sensors like the PS sensors or the soil acoustic sensors and uh, sound sensors where it's going to be very less cost and it can be used by everyone in future.
Okay. Yeah. Okay. That's it.
Uh,
Thank you.
Thank you so much for your presentation, ma'am. Now I'd like to call upon our next presenter. Our next presenter for this session is Snehal Kavatkar presenting a paper on the title Urban Fix AI Smart Reporting System for Road Safety and Management. I request you to kindly take over with your presentation, please.
Thank you. Is the screen visible?
Yes, ma'am, your screen is visible.
Okay. Uh, so good afternoon, everyone. Myself Snehal, and my teammates are Sanskriti, Prajwal, Shreya, and I'm going to present our project topic Urban Fix AI Smart Reporting System for Road Safety and Management under the guidance of guide Professor Ashwini Zarari from I2IT. So these are the contents I'm going to present today. So smart roads are crucial for transportations and have been a part of human civilizations since 600 BC. And their maintenance is essential to prevent accidents and delays. Potholes are common issues caused by poor maintenance and various environmental and human factors. Therefore, there is a need to automate this process that detecting the potholes and improving the maintenance speed. So as you can see in the picture, that the roads are in very bad conditions, which may lead to road accidents causing a loss of life. So our motivation is that accident prevention, because pothole contributes to accidents and pothole detection systems can help prevent collisions caused by sudden jolts or loss due to sudden loss. Next is driver safety is also important. By
Sorry,
minimizing the
Snehal.
vehicle.
Sorry to interrupt, but your screen is freeze. Like, you cannot see your next slides. It is just
Uh,
appear.
okay. So, by minimizing vehicle damage and accidents, pothole detection systems lead to significant cost savings for individuals, municipalities, and transportation agencies. The problem definition is that the potholes on roads causes vehicle damage, traffic disruptions, and accidents. And there is not a current system which allows the user to report the potholes with their locations. So our project uses YOLO version 8 object detection algorithm to identify the potholes from images and send their GPS coordinates to the authorities for faster road maintenance. So as you can see that the proposed system says first of all we need to register, and the login credentials will be provided. After that the image should be captured using the camera of the phone, and then the potholes will be detected from the image. Also the system will fetch the user's current locations, and the email will be sent to the municipal authorities. The system also provide a feature for user to track their complaints, and the authorities will update their status of the complaint. Furthermore, the complaints will be distributed by the authorities to the particular department for filling the potholes. The system also provides the user to give feedback and rating systems. So this is the system architecture of our system. As you can see that image acquisition is completely from the camera. We are not providing that the user can't upload the image from gallery because we are currently fetching the GPS coordinates. So for fetching the current GPS coordinates, we need the live image. The image pre-processing is done by resizing and normalization techniques. Then we have used the YOLO version 8 inference. We have trained our model on the RoboFlow, and we have given the inference to the so our system. Then the model will detect the potholes in the image. Until and unless it detects, the image cannot be sent, because if we don't do that, anyone we can say send any image which is not related to the potholes. Thus it is required to detect the potholes from the image. We are fetching the GPS coordinates as latitude and longitude, and we are sending the email by using the SMTP mail server. After that, the user can track their complaint as given below, like it is submitted, or it is in review, or it is in under process or completed. Then the authorities will handle the further procedures. So these are the project modules, that YOLO pothole detection module. Uh, YOLO module is used to detect potholes in real time. Then data transfer and GPS module sends pothole detection data, including images and GPS, to the backend server. Then next is the backend server and database module for storing the pothole related images. And web application, as we can say that we have provided the web interface for map, and we can count the potholes in the particular areas, and also we can detect the severity of that, whether it is high or low severity. So these are the results of our system. So this is the login page where user can enter the email and password and log in. This is the registration page. If the user is not registered already, he needs to register before logging in. This is the home page after logged into the system. Then this is the pothole reporting page, where user need to upload the image. As you can see that we have uploaded the image, and the system is capturing the current location, that is latitude and longitude. We need to give the permission for that, for capturing the location. Next is we need to click on detect potholes. As you can see that the image is detecting the potholes based on the severity. The red indicates that higher the severity, and green is low severity. We can also write specific comments so that the municipal authorities can understand more. Then this is the complaint tracking page, where the total complaints and the completed pothole maintenance detected will be shown. The user can track the status of their complaint. This is the profile page for the user. This is the view map page, that you can see that we can see that how many potholes are detected in that particular area, and what is the severity, that low, moderate, or minor, like that. And this is the image which will be going to the authority, uh, along with the location and with image. Also user whatever complaint that user have written will be gone to the email. So in conclusion, the system effectively detects potholes using YOLO version 8 and reports their exact location, offering a smart and efficient solution for road maintenance and public safety. Thank you.
Okay, great. So, tell me, Snehal, have you identified the specification of camera?
Specification of camera means uh, we can use our mobile cameras. We have already deployed our project, so I can also share the link in this chat so you can see.
Okay, good. Because that is the first thing when any representative or official person is using this application, right? So
Yes, yes.
how many cameras on which road and what will be the distance between two cameras so that it will be integrated, right? So for that, I ask you, what is the camera specification?
It's not like that, ma'am. We are using our mobile phone cameras, so why do we need that distance and all?
Okay. But suppose if anyone is not using from their mobile and they're not reporting. So what about the automated?
Automated in case, ma'am, we are providing means user don't need to go to the email page and write the email and take the location through gps. We are directly fetching automatically the gps locations. The
Yeah.
main purpose, that is the automatically gps, and it is directly sending the email to the authorities. User don't need to add their authorities emails, because don't everyone know that what is the authorities email will be like that. So
Okay. Great. That's it from my side. Thank you.
oh, okay, thank you, ma'am.
Thank you so much for your presentation, ma'am. With this, we come to the end of our session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within the 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank our session chair, Dr. Priyanka More, for chairing our session. This is a token of appreciation from our ICT team, ma'am.
Yeah. Thank you,
Ma'am, would
ma'am.
you like to say a few final words before we come to the end of the session?
Yes. Thank you. Thank you, organizers, for giving me this opportunity. And for the participants, thank you all for being part of this conference. I'm being associated with this conference since the last, I think, 2 conferences. And it's the really, they are organizing in a good manner, good organization, and really, really good work I have seen through this conference. And all the best, you all, to do more research in your topics. Whatever questions I ask you, just consider this as positive comments, positive feedback. Yeah. Thank you. Thank you all.
Thank you so much, ma'am. Thank you so much for your valuable presence. Now, I just request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual conference. Thank you so much. Stay safe, take care. Thank you so much for being here for this meeting. Thank you.